Hi, in this video I have a double integration problem. I want to integrate the function natural log of x squared plus y squared divided by the square root of x squared plus y squared over the region given by this inequality. I suggest you pause the video, try and solve the problem yourself, then come back and see how I solve it. Okay, so the first step in this type of problems is to sketch the region. Here the region is defined by this inequality, and it looks like it's going to be a circle because we can rewrite it as r squared bigger than or equal to 1 less than or equal to e to the power of 3. If we take the square root, we get 1, we have r, and we get e to the power of 3 over 2. So now we can sketch the region. So we're going to have a circle of radius 1, and we have another circle of radius e to the power of 3 over 2. And the region is everything defined between these two circles, which is a circular disk. Okay, by looking at the region, we see it's circular, so it would be a good idea to use polar coordinates. Another reason we should consider using polar coordinates is the function. We have x squared plus y squared, which is usually a good hint to use polar coordinates. So now let's set up the double integral using polar coordinates. So I'm going to have natural log, instead of having x squared plus y squared, I'm going to have r squared. And we have the square root of x squared plus y squared, which is equal to the square root of r squared, which is equal to r. And since we're using polar coordinates, we have the Jacobian r, we have dr d theta. Now we need to figure out the limits of integration, and since we're using polar coordinates, we're going to have to go to the origin, and we're going to sketch arrows going radially outwards in all directions. So you see that we always enter the region through this circle here, which has a radius 1, and we always exit the region through this circle, which has a radius e to the power 3 over 2. So the limit is going to range from 1 to e to the power 3 over 2. And since the region is defined in all 4 quadrants, theta is going to range from 0 to 2 pi. And of course, this r cancels with this r. So we can rewrite this. Here I have natural log of r squared, so we can rewrite it as 2 natural log of r, and I'm going to take the 2 outside. So I have 2 from 0 to 2 pi, from 1 to e to the power 3 over 2, and I have natural log of r, dr d theta. So how do you integrate this? If you remember from calculus 1, the integral of natural log of r dr was equal to r ln of r minus r plus c. So I'm going to have a link somewhere here on the screen to show you how we figured this out using integration by parts, if you don't remember. Okay, so let's evaluate this. We're going to substitute the limits into this here. We're going to have e to the power 3 over 2. So if we're evaluating this part here, natural log of e to the power 3 over 2 minus e to the power 3 over 2. We have a minus, we have 1, natural log of 1, minus 1. So if we simplify this, of course we can take this e to the power 3 over 2, we can rewrite it as 3 over 2, e to the power 3 over 2, natural log of e minus e to the power 3 over 2, minus, of course natural log of 1 is equal to 0, and we have minus negative 1, which is positive 1. And the natural log of e is also equal to 1. So we have 3 over 2 minus 1. So we end up with 1 half e to the power 3 over 2 plus 1. So now let's proceed. So now we're integrating this over here, e to the power 3 over 2 divided by 1 half, divided by 2 plus 1. And we're integrating with respect to theta. Remember, we had the 2 outside, and we're integrating from 0 to 2 pi. Since we don't have theta anywhere here in the function, this could all be considered as a constant. And we can have e to the power 3 over 2 divided by 2 plus 1. And we'll multiply this by 2. We're integrating 1 d theta from 0 to 2 pi. Now if we solve this, you should be getting 4 pi multiplied by e to the power 3 over 2 divided by 2 plus 1. And this over here is the final answer. I hope this was helpful. If you have any questions, leave them down in the comment section below and I'll be more than happy to answer it.